This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. So last session, we were discussing about the different topics, right? So what is that? Let me open that. Yeah. So yesterday we were trying to talk about these particular topics, and so over here, so we all talked about how to create a load balancer, how the load balancer works, and then we went with so a single load balancer. How do you redirect the traffic to multiple services in the backend, and also the next thing, okay, so are our servers going to be a public or private, right? So we talked about the network and the design. So basically when you choose the network, the points we're talking about is so first of all you have to design your network size. Okay, so based on your network size, okay, so we need to, based on our network size, we need to okay, so choose the range basically. Okay, so based on the capacity requirements, you need to choose the network range, and we have chosen the range like so some 256 IP address from 190 to 168 series. So yeah, we can do that basically. Okay, so we are going to create one VPC with so asking for 24 IPs reservation, and you get that. And after that, you cannot directly use it basically. So because VPC is virtual, VPC is a virtual one. So VPC is nothing but it belongs to one region. Go there. So VPC belongs to one particular region. Okay, so in the region, actually the resources are going to be there in some of the availability zone. Okay, so it actually is going to be under availability zone. So you take North Virginia, there are 6 availability zones, and yeah, so that means your server sits in any of these particular 6 availability zones, or you choose the availability zones and it actually sits in that particular availability zone. So availability zone is nothing but the data center. Okay, so now each and every data center you have to so you have to cut some piece and you have to give it to that particular availability zone. We have to cut that particular one. We have to cut that particular network, and we have to give we have to cut the net, we have to cut that particular VPC network, and we have to give a small chunk to that particular to that particular data center. So where the servers are getting created in that particular data center, so we'll be using this particular VPC network. Okay, so that's the idea basically. That is the idea. And these resources are isolated, that so one VPC resources by default will not talk to other VPC resources, and one VPC so resources will not talk to another account also, right? So Amazon is a multi-tenant application, so that means a lot of users are there, right? Isn't it? Not only you, everyone uses North Virginia. Not only me, you are also using North Virginia. So that means this application, whatever actually they have developed, is a multi-tenant application. So, and even the network also, it's an isolated network. So that means our servers will never be communicating to the other account servers unless until you open the connection. Okay, so that's the idea. So even one VPC also, I'll not talk to another VPC unless until I open the connection. So it's all isolated. And so yeah, the servers inside one VPC can communicate each other, even though those are under different data centers. So that's how the design is going to be. Okay, now so actually like let's say VPC, you have 256 IP addresses, and those particular 256 IP addresses you are going to take so those 256 IP addresses you are going to take and cut it into pieces, and you can use multiple availability zones. Now, how many availability zones I have to use? So there are 6 availability zones, isn't it? And which availability zone I have to use? That's a question mark. Okay, so there might be 10, 100 also, but how many I want to use? And based on the nature of my application, so basically we want to design a high availability application. So that should be 1 or more. The answer is 1 or more. How many more? It doesn't really matter to me, isn't it? So how much more, I don't bother basically. Okay, but it has to be one or more. They're not one. Not only we don't use a single subnet for high availability, because our the problems which we are talking about here is, so the scalability and availability, right? So the standalone servers are availability. So now if everything I keep it in one subnet, now if that, I mean one availability zone, and if that particular availability zone goes down, if that availability zone goes down, then yeah, so how do you do that? Okay, so one availability zone is nothing but one data center. So there's a chance that one data center completely can go down. Okay, so due to a power down, due to some natural disasters, whatever the reason, it can go down. Okay, while it is going down, okay, so other availability zones should be there to serve your request. Okay, so that's the idea. Okay, so just to avoid the interruptions basically. So I think minimum 2 subnets is fine for me. Okay, so for our application, if you want more, you can design based on that. So that is fine. Okay, and okay, so now we want to do the networking. So VPC design basically. So how our VPC should look like, and our VPC is actually going to look like this. So VPC is this one. Now this VPC is a bigger one, so which you are going to get 192.168.0.0 by 24. 24 is nothing but you're going to get 256 IP addresses. We already seen that yesterday, right? Now this one is going to cut into pieces. So now I'm going to cut into pieces. This piece basically is I'm going to call it as we're going to call it as subnet 1, so which is going to be used under availability zone 1. Okay, so then subnet 2, and we are going to put it to availability zone 2. That's it. We are going to do that to availability zone 2. Subnet 1, we are talking about availability zone 1, and subnet 2, it's actually goes to and this actually need to be cut into 2 pieces now. Now how do I cut into pieces? It is actually 0 to 127 is one IP address range, and 128 to 255 is another range. Okay, so that means if I just put it here, so it actually going to be the range of this particular IP address is 0.02 192.168.0.127. Okay, this is the first subnet range. Okay, and so the second subnet range is 127 is already done, right? It's actually going to be 128 to 255. Okay, this is the range of this one, and this is the range of this one. All right, and all right, so this is the design actually I'm trying to make now. So that means 128 IP addresses here, 128 IP addresses here. Okay, so I'm just splitting it. All right, in a shorter notation, this can be called as 192.168.0.0 by 25. Okay, so subnet calculator, go there, and if I give yesterday we were using yeah, mix toolbox. It's easier one to understand. So now if you just go and click on calculate, what is the starting IP address? 192.168.0.02, now 192.168.0.127. So it is nothing but /25, isn't it? So /25. Whereas the next one is actually going to be 127, this one. So calculate. Okay, so now if you go for 0 to 127 by 25, why is it coming this way? 127 sorry, 128 actually. Starts with 128, right? So calculate. Now actually it's going to be 192.168.0.128 to 192.168.0.255. Okay, so this is the another network range which you need to modify. So slash 25. Okay, so all right, so this is how I just cut into two pieces, 128, 128. All right, now my servers, whatever I create, I'm going to keep it over here. Whatever servers I create, I'm going to keep it here. So now the two servers yesterday, whatever we created, I'm going to keep one server in one subnet one, another server in another subnet one, subnet two. Okay, so but I want to, okay, but I don't want to make these servers public, right? So that's what we are discussing about. All right, so what is the problem? Actually, the thing we're talking about, okay, is all servers going to be public? Is it secure? No, right? So that's what we're talking about. Okay, the servers are having security issues, then there can be compromise. Make your servers less vulnerable. Okay, and is the servers ready? I mean, really need to be in the public internet? No, keep all servers in private network. So that means these servers will never be exposed to the outside world. Okay, so now let me just create one server first of all, but before to that, even I need to create a VPC. Okay, I'll go and create VPC. I think yesterday or day before yesterday we created one VPC already, it seems. Okay, that's fine. Create a VPC. So this VPC is going to be is like, let's say, okay, so like let's say RoboShop VPC. So the total IP address you want is 192.168.0.0 by 24. Okay, this is the range I'm looking for. Created. So the VPC is created. So that means 256 IP address. On the down you have subnets. Okay, so the subnets I'm supposed to create now. So create subnet, and you go to the which subnet you want to create. So 192.168 series, right? This one. And no, RoboShop basically. I think yesterday also I created a test one with 192.168 only. Let me delete that in that case. So this test one is also the same thing. Okay, so since these two networks are isolated, even it can allow you to create another VPC also with the same range. There is no problem. So generally people ask this tricky question in the internet. Okay, if I have a VPC with certain range, and can I go ahead and create another VPC with the same range? The answer is yes, because by default those two will not communicate, so there is no problem. So for you, those are sitting in one account, but if you technically look, those are isolated two different pieces. Okay, so that's the reason. Okay, so you can do this. I'm just putting like RoboShop, only one, but usually no one will actually overlap the networks. Okay, don't actually try to put a conflict. That's a problem. Okay, so when you want to connect the two networks, that becomes a problem. Okay, until then it is fine. All right, and so now I go to the subnets. I want to create a subnet, and I'm going to say that so this is 192.168 RoboShop 1, and so here I'm just calling it as subnet 1, and which availability zone I want to go with 1A. So first availability zone, and what is the IP address we are looking for? 192.168.0.0 by 25. Okay, so that's the range you're looking for. Create subnet. Okay, done. And so you got one subnet, and create another subnet. So you have like let's say, and subnet 2, and so here availability zone is 1B. So you should not choose 1A again. It will allow you to create multiple subnets in the same availability zone. That Amazon allows you to do that, but you should not do that. You always have to go and distribute your traffic to multiple availability zones. Now 1B is the one. So so which is 192.168.0.0, no 0.128 by 25. Okay, so click on create subnet. Okay, so out of 128, always you'll get only one, -5. How much network you design, you always get -5 IP addresses. Okay, 5 IP addresses will be reserved by Amazon for making your network to work. Okay, so 5 will not be there. So now this is the 2 availability zones you have. Okay, in the worst case, let me put a question to you. Okay, or like let's say you're attending the interview, so the next question would come is, okay, so like let's say I'm just talk about on VPC. Now let's say I'm done with the subnets, right? So I designed in such a way that I took 256 IP addresses, and after the 256 IP addresses, I'm done basically consuming all the IP addresses. Like let's say I created subnets, 2 subnets, I just give it 128, 128. So tomorrow I got a requirement to add 2 more subnets. I got a requirement of adding 2 more subnets. So now what do? You destroy them and recreate again, cutting into 4 pieces? No, because by the time your resources already start running onto your subnets, you cannot delete your subnets. Then what do you use? This alternate solution. You go with another VPC. That's one thing. So, but that is an earlier strategy. I think almost a couple of years back only, Amazon has introduced one more option, which is called as um, edit CIDRs. You go with the CIDR and you add a new CIDR. So if you're done with, so the next done with the IP addresses 192.168. Now 1.0 by 24. Okay, so there is 2 more. I mean, sorry, I didn't actually save data. Edit CIDRs. This one 192.168.1.0 by 24. Okay, is something you're adding. Now you got 256 more IP addresses to the same VPC only. To the same VPC only, you got the multiple IP address. So this is the strategy generally people will try to take. If you are exhausted with the IPs, okay, you don't want to really create another VPC and do some work. Same VPC only, you can add another network range also. It works. That Amazon supports this. All right, so that's where you can do that, and I'll just delete this for now. And now you can use the subnets using this range. Now it works. All right, so that's how you created the 2 subnets. Now I'll go and try to create a server inside the one of the subnet. Okay, so I go to the instances, launch instance. Okay, my MI, and something is okay. T2 micro is fine, and now I'll go for the request spot instance just to save the cost, which is fine. And now the network. So the networking part. So I want to choose the RoboShop as a 1. Okay, so which availability zone, 1A or 1B is your choice. I'm just choosing 1A, and so you just chosen that. So click on add storage and add tags, name node 1, configure security group. Okay, so you cannot use the previous one. So because this is a new VPC, that allow all to public will not be there. So it automatically picking someone which opens the 22 port. Debian launch, we don't require a key pair. So proceed without a key pair, launch instances. Okay, so view instances, let the instances come. So the instance is actually pending, let it come to running. I think the server would be running now. Let's take a look. Yeah. Now, how to connect to this? There is no public IP address. How do you connect to this? Okay, so there are multiple ways of connecting, as I mentioned. Okay, there are multiple ways of connecting, and the connections could be something like this. Okay, so then if all your servers are all your servers are private, so then how do you reach your servers? Either you create a VPN software, okay, and so you create a bastion node, or direct connect. So direct connect is the one most of the companies uses. If you have a direct connect, so that means there is a leased line actually taken from Amazon to your account to your data center. So there's a dedicated line. So that means if you are in office network, you can directly reach to Amazon. Okay, so over the over the IP address. All right. So now let's say, okay, so I am actually in one of the VPN. All right. So I'm already connected to one of the VPN. So now I can just go and so really I can go to SSH. Yeah. So like let's say this is a 10.155. 10. Series is also a private IP address, right? So but of a class A. So now if I hit enter, I'm able to log into that machine. But this machine doesn't have any public IP address basically. Okay. So it's an internal address, then you can connect. Okay. But direct connect is too costly. So we are not actually company guys. There should be some devices procured to connect them. Okay. So that's not our choice. Okay. So this I cannot go with. Our requirement is I cannot go with this. Because yeah, as I mentioned, so it is okay, it is not our solution. Then what is the alternate solution? So we have to go with the VPN. So Amazon itself offers, okay, so Amazon itself offers a VPN. Okay, so now you can go to here, and in the left side, so there's an option which is called as client VPN endpoints. You can create a client VPN endpoint, and so you can use this. Okay, but this is also it's a VPN software which is provided by Amazon out of box to connect to your VPCs. Okay, you can do that. But in order to do this, okay, so you require internet to that machines. You require an internet. Okay, so that is another problem. Okay, so but we don't have internet to those machines because you just created the subnet. The internet part we didn't talk about that. There's one thing, and again this is also a little costly service. Okay, even I don't want to go with this also. Okay, so what I can do is I can install some VPN software inside my account. Okay, inside my account, inside my VPC, I can create one VPN software servers like OpenVPN and all. I can use these are cheaper basically. OpenVPN, so some solutions like these are cheaper. Okay, even you get it here if you go to try to launch an instance. If you just go to launch an instance, you go to the marketplace, you get OpenVPN out of box. You don't really do anything, so you can just use OpenVPN. So it depends upon the number of users you're looking for, you get that. Okay, so OpenVPN for 10 devices, 25 devices, okay, so 50 devices, 100 devices, 250, like this, based on your number of devices. Okay, you have some pricing coming up here. You pay that and you get it out of box. Okay, that's another option. Okay, this is the cheapest option basically to talk. Okay, and why? Because here this particular client VPN software will not provide any username and password. If someone have the file, they can get into the network. If you lost, if you have a file to share with another one, he can directly get into the network without any username and password credentials. This is a kind of a little tricky part. Okay, so I don't want to go with the client VPN also. All right, but then what is the alternate way I have here? Okay, I mentioned another third way also. So what is the third way is telling? It's a bastion. So VPN also I don't want to go with, as I mentioned. So I want to go with bastion. Okay, what is bastion? Bastion is nothing but an English word. Okay, it's not technically related to so it's not technically related to any what we call software, but basically it's a bastion. Like if you have any kind of so old days you used to have some forts and all, right? So there's a front wall, so which is actually a single entrance to your fort. The rest of the fort is completely closed. Okay, so but actually the rest of the fort is completely closed. Only one point will be there to get in. All right, So in technical talking about, so here is the bastion. You see this? So this entrance, whatever you talk about, that's bastion. Only through that entrance only you can get inside. Okay, so that's the idea. Okay, that approach actually is taken by here as well. And this particular bastion now is a server. Okay, one EC2 instance. That EC2 instance, you connect to that EC2 instance. That EC2 instance will give you connectivity to all the instances. So that's the idea basically. That is the idea. Okay, now where to create that particular bastion? You create on the same VPC, or you create on another VPC and give connectivity to your VPC. Either you put that particular bastion node in the same VPC where you created, or you keep it the outside of the VPC and keep it in some other VPC and you connect it from there as well. So anything is okay. Anything is okay. So that's the idea. So it is a very cheaper solution. But again, so generally people who are from Linux background, so you usually will have a question that, everyone logging into the same machine, how do you track that, who is going where and things like that? Okay, yes, that's a valid question. Okay, if you take a normal Linux instance, so probably who is getting in, who is getting out, you don't really know. Yeah, obviously. So that is where some third-party softwares are there. So something like this, Bastillion.io. So this guy is actually a Bastion software. Okay, so but which will track everything what is happening inside system, who is connecting, okay, so who is going to which machine and things like that. So they will try to track and give you a report. Okay, so that you get even a two-factor authentication to log into the machine of Bastillion. And so yeah, so they kind of provide some standard things here. Even they provide the product from the marketplace also. You take it, use it, and pay for that. Okay, so that's the idea of this. Okay, so yeah, so that's how you can do that. But I don't want to go with this software. I'm just giving you the idea. So if someone, so these questions will be tricky when someone asks you in the interview. Okay, so I would definitely ask, at least if you say Bastion, then the next question I'll ask you, how do you control your how do you audit your so the authentications, which is actually going through Bastion. So yeah, so if you simply say Bastion, it will not work. Okay, you have to say that you are using some third-party softwares that work for that. If you're really interested, so this is the software which is really going to be helpful for you, which is Bastillion. Okay, all right, and yeah, so for me it is going to be a simple Linux instance. I'll be just using a single Linux instance. So I already have one Linux instance. If you see, I already have a workstation. Why don't I use this? So that means in order to do a connectivity to these systems, so what I'm going to do is I'm going to use one VPC which is already there, or the server which is already there. I'll be using it. Okay. What happened? This is your VPC, and I'm going to have a default VPC which is already there. Okay, so a default VPC is already there, and a default VPC is already there, and inside that, so there is an EC2 instance also is there. Okay, so there is a Linux box is also already there, which I'm calling it as workstation. So workstation EC2. Okay, so it's a EC2 box. Now what I'm going to do, I'm going to connect to this particular one. So I'm going to connect to this one, and okay, I'm going to connect to this particular box, and from this particular box I'm going to get in here. Okay, so from from this box only we'll allow access to this. Okay, so how do you do that? How do you do that? Okay, so let's give a try. So first of all, you already created a machine node 1, and let me go to workstation. So I'm going to log into the workstation, and give me 1 second. I'll just trigger this. Yeah. So here, DevOps 321. All right. So from here, what is our server IP address? The server IP address is a node 1 IP address. So this is the IP address. You didn't did any configuration, and technically it will not work. Okay. So you have to do some configuration. So what you have to do is you have to open a connection between these two guys. Okay. So first of all, what you have to do is you have to open a connectivity between these two guys. Okay. So how do you do that? So you have to enable some connectivity between these two guys. Okay, you have to open some kind of tunnel so that these guys can enter here. Okay, so or these guys also can enter here. All right, so you just need to open some tunneling, and that particular tunneling is open some tunnel. Okay, and that tunneling in here is called as peering. Okay, so VPC peering. You're going to do a VPC peering between these two things, so then these two networks can talk to each other. Okay, that's the idea. Now how do you do that? Okay, you go to the VPC, and you go to the VPC, and you go to VPC, and you go to the peering connection. So there's a peering connection. You click on peering connection. So there's no peer connections. Click on peering connection. So this is to default to RoboShop. Okay, VPC. All right, and so here it is RoboShop, and here it is going to be my account. You can peer with another accounts also, and this region, or you can peer with another regions as well. Okay, so it is my account, this region only, both are. So you have to go with choosing the RoboShop guy. Actually, so no, this is already this one. So here it has to be normal default VPC. You have chosen the VPC requester is the RoboShop guy. Actually, peering request happening to 172 default VPC. Create a peering connection. Okay, now the peering connection will be pending because you only have to accept it because you're the requester and you're also the acceptor. So then that your peering connection is active. Okay, my peering connection is active. Can I go and hit it? No, it's not working. Okay, so peering connection you just established. Okay, so but it is really not ready to reach your reach from your network to that network. So why? Because the route, basically the scope of the network is actually still going here only, is rotating here only in the VPC. So if there is a route added to that one, then it can go here and reach to the other process, or this one actually should go here, means so this VPC should be knowing that, so the network should know that it can go to this network also over the peering connection. You got my point? Okay, so it is saying that, so it's showing a road basically. I mean, by default, the visibility of your network or the scope of your network is still on VPC. You can tell to your VPC that your network that, hey, you can start reaching the 192 series network over the VPC peering connection. You can tell that. You have to tell that actually. So how do you tell that? You go with the route tables basically. So you go with the VPC route tables will be there. So every subnet is going to have one route table. So you take the default VPC. These are the default VPC subnets, and it will be having some route tables. Let's go to the route tables. You have two route tables, one route table for the default one route table for the new one you created. Now the old one, I have to tell that, hey, I want to add a route, so you can start reaching 192.160 192.168.0.0 by 24. Okay, you can reach over the we can reach over the peering connection, and you click on peering connection, and there's a peering connection. That's it. And to this guy also you have to say that, you know, so here this network. So you have to also go to this one, go to the routes, edit routes. You can say that, hey, yeah, you can go here over this network. So you can go to the peering connection. Over this peering connection, you can reach there. To both the networks, you have to tell you can go to other network over this. Okay, over this peering connection is what you mentioned. Okay, so to both the networks. So this network also I told, this network also I told. Okay, to both the guys, I am telling that use peering connection to reach here, to reach here, this to reach here, this to reach here. Okay, both I told that in route tables. Now if I go and give SSH, now it's working. You got yes, yes, and DevOps 321. You're into that particular machine. So this is how, you know, so the bastion part I came into. Okay, or else you can go with, you know, the same instance on the same VPC, but yeah, in order to make it, so that particular machine has to be publicly open. Okay, so which I don't want to, because all my application servers, all my servers has to be private. I want to keep that way. So only one server which I make it public is another VPC. I'm doing it. Okay, it's even a good idea even. Okay, so yeah, so that's the idea about VPC peering connection. So any questions on this so far?
Yeah, Harsha, this is Manoj.
Yeah.
So like the route tables and all we will create through VPC peering. You mean like
Sorry, come again.
the route tables and all we will create it through VPC peering or?
No, route table you can create it with any. Route table is one of the one. Sorry, peering connection is one of the one. There is some noise on your side. I just muted you. Yeah, so peering connection is one of the one to add a route. Okay, so it's not like only peering connection you should add a route. Route is a simple entry basically. Yeah, and VPC peering connection is one of the one. Got it? You have been muted. Yeah.
Yeah.
Is there a logic between accepting VPC for peering? Yeah, there is a logic, right? So that means, like, let's say you're actually trying to open a peering connection between another account. Okay, if I know your account ID, I can just open I can give your account number and automatically, I can give you a VPC ID. So that means actually I cannot get into your network, right? So logically you have to accept it, isn't it? Otherwise there is no security in that, right? I can connect to anyone's actually inside Amazon. Okay, if I know some information basically, all right. So just to avoid that, so the accepting the peering connection is the right approach in general, yeah. Anyone? Any other questions?
No, what I meant was, Rahu, that the way, like, the way you in the interface you chose the accepting VPC as the one on the 192.168.0.0/24 subnet. I mean, not subnet, but that IP range. Can I flip it? Should I?
Yeah.
Okay.
So it is the same account, you can flip it. Basically, you think about different accounts, you cannot flip it, right? you are actually requesting the other guy, so it has to be your VPC only all the time requested. Yeah. All right. So yeah, so finally you're able to reach to that machine, and which is fine. Let's say I want to install a web server inside of this so that I can just go and create a load balancer and make it public and accept it. So now I'll just go and give sudo yum install nginx -y. So it will be just stuck there. It will never give you any output. Okay, it will just stuck there. If you see this, just stuck there. So why it is actually stucking? Okay, why is actually stuck? Right, so the point over here is actually you don't have internet here. So ping google.com. Okay, you don't have internet. You don't have internet. Okay, that's the reason. So you need to add internet to these particular subnets as well. Okay, so yeah, but how do you add the internet? Okay, so adding the internet should be done with a little bit big approach here. So first thing first, if you want internet, okay, so that means you should be having, and okay, forget about internet. Okay, let's say keep it internet aside. Okay, so the same point actually, so we were discussing in yesterday's session also. So if I keep it all my servers in, if I keep all my servers in private, so then how do public people can access my network? Or I'm hosting a RoboShop application. How the internet people will try to people over the internet will try to access my application? So that's still not possible, right? Yes, that's still not possible. And to make it possible, so what actually we need to do is we need to keep the load balancer in public. We need to keep the load balancer in public. And whenever you try to create a load balancer, it choose the VPCs, choose the VPC along with subnets and all this. Sorry, load balancers. And if you go to create a load balancer and create it, you will be definitely choosing the VPC. Okay, so and you will be choosing the subnets. Now these subnets doesn't have internet, so these cannot be accessed from the outside world. Okay, and so that is where, so we can call these as private subnets. Okay, these subnets, whatever we have so far, is called as private subnets because those are not really those are not really need to reach from the outside world. So that's where these subnets are private subnets. Okay, by default the subnet you create is a private subnet only. Basically it's a subnet is a subnet, you call it as a private. Why? Because it's not actually accepting to the outside world. Okay, now what I want to do here, okay, so now what I wanted to do here is I want to create two more subnets. Okay, so two more subnets, so stating these are public subnets now. Okay, so now your design has to be public subnet 1 and public subnet 2. Now whenever I create a load balancer, I'll put that particular load balancer in these particular subnets. Okay, and whenever I create any instances, so those instances will be sitting here. Okay, so simply if I say EC2, okay, now the traffic actually will come from now the traffic is actually going to come from internet, okay, to the load balancer, and this load balancer is actually going to put the traffic to the EC2 instances. It's all the traffic to whatever it is there from EC2 instances. So that's the idea. Okay, so this is what I need to do. So for this actually I need to make something called as a public subnet. How do I make a public subnet? Okay, so while creating any subnet, it never asked actually it's a public or private. We don't have such options basically, right? So then how this is coming? And now these numbers is also not enough actually. Why? Because you already gave 128. So how can you use a public subnets? Okay, so this is the thing actually is a problem for me now. This is a problem for me. I have to design it. Okay, so how do I want to design? The network range is still same, like let's say, but I don't want actually, so 128 IP address. There are 4 subnets, right? I'll cut it into equal parts, even parts. So I'll just go with /26. So /26 is nothing but you'll get 64 IPs only. And here also you will get, so here it is 64.26. Okay. And so what is the next one? You can make it here is 128 by 26. And the final one actually going to be is 192 by 26. So you actually putting into 4 subnets. Okay, and 4 subnets looks like this. All right, so now I'll just go to the subnets. So the 2 subnets, whatever I have, okay, I cannot delete them because my server is already running there. First of all, I have to terminate the machine. So that is the reason actually you should always carefully choose the network design. Okay, so you cannot actually terminate the instances in the real time just to change some network. Okay, so that's not a ideal good part. Okay, your instance got terminated, so now you can go to the subnets and I'll say delete subnet. So now you can just go and say delete. Those 2 subnets are getting deleted. Now I'll create 4 subnets. So 2 are actually I'm going to call it as public and 2 are going to call it as private. But carefully, observe there is no discrimination while creating the subnet. So I'm going to say that this has a private hyphen subnet 1. So, but there is no discrimination telling me that I should use this is a private or public. Nothing. I don't see anything. Okay. So yeah, but why do I call that? I'll talk about that. 192.168.0.0 by 26. Okay, so this is the one. Create subnet. Okay, and again create another subnet. So here it is this, and here it is this. It's actually to 192.168.0.64 by 26. Okay, so create subnet. Subnet, and then I'll go to RoboShop. Now I'll go for public. So actually I doubt actually which, one second, private subnet 2, how I got created both in the same availability zone, both in the same availability zone. So that's a wrong thing. I have to choose the appropriate one. So sorry, let me delete this, delete subnet, delete. It has to go under the second availability zone. Create subnet, and this one actually going to be private hyphen subnet 2, and actually going to be 1B. Okay, so 192.168.0.64 by 26. Okay, so here it is Bushop. Now I'll go to the public subnet 1 and 192.168.0.128 by 128 by 26. Okay, create subnet and create another subnet which is this and 192.168.0.192 by 26.
Raghu, for public, you don't need to create a availability zone.
I didn't choose an again. No? Yeah, I chosen somehow. Yeah. 1A, 1B, 1A, 1B. Yeah, there might be some delay on your screen. So yeah, otherwise it was. Yeah. All right. So now I got 4 subnets. Now, is there any discrimination while creating the subnet? Is it private or public? You are writing a tag. This is just a tag, nothing more than that. Okay, so this is not really a technical thing. Okay, then how do you say that this is a public subnet or this is a private subnet? Okay, so the only thing which actually tells whether it is a public or private is there's an internet gateway. So if you take the internet gateway and attach the internet gateway to the subnet, that is a public subnet. That subnet can be reached from the internet. Okay, that's the idea. Internet is the gateway to that. Okay, to gateway of to that particular subnet is internet. Okay, so that's where I'll go and create an internet gateway. So I'll say something like that, create internet gateway. And now this particular internet gateway you have to attach to a VPC. Okay, on the top you attach VPC. Which VPC I had to attach? RoboShop VPC. Attach internet gateway. So now you attach internet gateway. Immediately you get the internet? No. You will not get the internet. You have to go to the subnets and to the route table. You have to add that particular one. But all are using the same route table. If you see this, so you're already having this public subnet. Sorry, public subnet one. You're already having this private subnet. All are actually having the same routes basically. Now there should be some isolation between private and public. So that's where I'll go and create a route table. And I'll say that create a route table. This is so this is RoboShop public hyphen route table. Okay, so the VPC is this, and create it. Now there's a public route table, and this public route table, and there's a route, there's a default route, and I want to edit routes, and I want to say that 172.16.0.0 by 16. Okay, I should be reaching with the peering connection. So the same peering connection I added, and along with this I am also going to add now edit routes. I'm going to add 000, so that means internet. So 0000 means the whole globe. Yesterday I was trying to create one globe diagram, right? So that whole globe actually denotes as 00000. Okay, now I would like to go and reach this 00 through internet gateway something. So now the instances in this particular subnet is actually reachable from outside world. At the same time, those has internet as well. Okay, so that doesn't solve another problem here. Let me just go and try to launch an instance. So just go with this security group, and now you choose this one, and you choose the private subnet only, still private subnet 1 or 2 or whatever it is, and you just create add storage, this one security group, let it create a launch, proceed without a key pair instances. Now your private subnets are still having a route table of route table of the traffic is still only these two. Internet is not there, 000 is not there. But if I attach internet gateway, what happens? If I attach internet gateway, it becomes a public one. No, if it is a public one, outside people can reach it. I don't want to do that. And at the same time, I want internet also. Then how do you do that? Is there is something called a NAT gateway. NATing gateway. NATing gateway is nothing but your Wi-Fi router. In your home, you have a Wi-Fi router. Actually, what you're taking a lead, one connection actually from internet. You're distributing the traffic to multiple devices, isn't it? The same thing here also happens. Okay, NATing gateway is nothing but you're going to take a internet connection from the public subnet, okay, and distribute only the internet to the remaining remaining servers, or basically subnets. You're going to take one connection from public, and then you're going to distribute that to remaining subnets. Okay, so how do you do that? So that's where create a NAT gateway, and NAT gateway creation is actually telling so something like ngw, which subnet you want to choose. I want to choose a public subnet. Okay, so from public subnet of 2, I want to take the internet, and I want to allocate one IP address for that. Okay, you get that network from this particular subnet, and you create a NAT gateway. So the NAT gateway will take 1 or 2 minutes of time. even 1 or 2 minutes, at least 3-4 minutes of time to get it created. Okay, so after it gets created, then what you can do is you can go and say that, okay, so your private subnets, what you can go ahead and say that is, hey, I want to get the internet from these particular instances. But in the meantime, so you got the new node 1. You got the new node 1. So this is the one. So, but I'll just you. Okay, I'm able to log into the machine. So ping google.com, ping google.com. You're not really gonna get anything. Okay, so let's wait for okay, this NAT gateway to be created. Then we'll attach the NAT gateway. Then we'll see the ping. Okay, so we are going to get it. Now, certain questions over here is, so what is the difference between private subnet and public subnet? The private subnet, sorry, the subnet with internet gateway attached is called as public subnet. Where you don't have an internet is called as internet gateway is called as private subnets. Okay, but for private subnets to get the internet, so we use NAT gateways. That's it. Okay, to get the internet, you use NAT gateways. That's it. Okay, so that's the idea. So the public and private subnets, public subnets which are attached with internet gateway is called as public subnets. Where you don't have internet gateway, those are private subnets. Yeah. Any questions in the meantime while it just takes another 2 minutes to create it? Okay, my NAT gateway is ready. So now I go to the route tables and say that this is the old route table. I'll say that, hey, you can reach 000. So that means the internet basically 0 by 0. So using NAT gateway and this one, save routes. Okay, so now you give ping google.com. Just wait for a minute, it will work. Just takes a bit time.
Raghu, don't we need a route in the private?
We added, right?
For the NAT.
Yeah, so this was NAT gateway we added. Why the internet is not coming? Gateway NGW is actually taken from this subnet, and this subnet is a public subnet too. Okay, public subnet, and its route table is okay. So public subnet route table I need to modify. Yeah. So I go to the subnets. Actually, public subnet 1. Actually, I modified the route table to go with public subnet 1, public subnet 2. Both are actually coming to the NAT gateway. So private subnet 2. Okay. Actually, to the public subnet, the route table whichever I attached it, I did modify it. So means, so edit the route table association. So I had to put the public route table. Yeah, it's a loop there. And this one also is actually going to be from the route table, and edit the route table association. It actually has to be a public route table. For public subnets, it has to be an internet gateway. Okay, so you see the route table now. You see the internet gateway. Public subnet 2 route table. You see the internet gateway. Public subnet 1. You see the internet gateway. Whereas public subnet 2, it's actually a NAT gateway. Public subnet 1 is also a NAT gateway. Okay, now yeah, now it will come. Yeah, you see this, the internet is coming. So we are doing nothing basically. You're taking a connection from the public and you're distributing like your Wi-Fi router. However, it actually distributes the internet. It actually distributing in that way. Okay, so that's how it is actually going on. Right now you got the internet, but none of these machines is actually exposed to the outside world, and so can be accessible. Okay, so can be accessed only internal, the SSH access and all. But the service which I'm going to run now here, yum install nginx -y. Okay, done. And systemctl start nginx. So, but this service has to be reached from the outside world. I cannot give a private IP address, right? I cannot go and take the private IP address unless until I'm under VPN. I cannot access it. Okay, but the public people still need to access this particular Nginx service. But how do they do that? So we do that by using with the help of a load balancer. So now I'll go to the load balancer and I'll create a load balancer. So it is an application load balancer, and it's actually going to be name is just Nginx, and it's an internet facing one. And I'll just go to the RoboShop, and so I'll be choosing the appropriate subnets. So I have to choose the public subnet. My load balancer has to be in public, right? So this actually has to be in public. Okay, that's what actually my diagram is telling you, right? So here you put the load balancer in these particular public subnets, and it can solve the traffic of the private subnets. All right, so now you go on the security group, choose, and I just go with create a new security group opening the 80 port, which is fine. Configure routing, the new target group. So there's a DG, and so you're going to hit HTTP port 80 and all fine. Register targets, you have only one instance, add to register. So you create it. So my load balancer will get created, and after its creation, okay, so it will work as expected. Okay, so let's wait for a minute for it to create. So let's see, where does it become ready? Still provisioning only. Any questions in the meantime?
Can you show the routing one more time? I mean, just on the screen.
Yeah. So the public route table, I'm saying, okay, so whichever is attached to the subnets of public, okay, so what I'm telling here is route table. So these are the entries, right? So my my local network will be there. So that means all instances inside, all the network inside the VPC can connect each other. So this is a default one. and so my another network can reach this route basically. Okay, so another network also you can reach. You're telling using the internet gateway, sorry, peering connection. Okay, so peering connection, you can reach this network using the peering connection. You're telling you're reaching the internet using internet gateway. Okay, so but to the private subnet you're telling that you can reach only the internet by using NAT gateway. So the internet gateway will allow the outside also two-side traffic. But whereas since it is selected as internet gateway, even outside people can reach it. Whereas the private gateway is given as NAT gateway, so that means outside people cannot reach you. So that means none of the persons from the other network from internet can reach your laptop because your Wi-Fi router is clearly blocking it. Okay, so it's only a one-way connection that it can go outside. I mean, you go to the google.com and get the content, but google.com will never, or Google server can never reach your laptop. Okay, that's the idea, and that's an NAT gateway. Make sense?
Yeah, thank you.
Yeah. Right. So I think the load balancer should be ready. Yeah, should be ready. Now you take this and put it on the browser. Now you're getting connection refused. Okay, did I started the Nginx start -lntp? Of course I started it. I think the security group of this instance is not actually enabled. Okay, if I go to the instance, if I go to the node 1, so the security group to this instance is opening only a 22 port. It also should open inbound rules. It should also open HTTP traffic, 80 port traffic for anywhere. Okay, so anywhere or local is also fine. To really make it anywhere, okay, you can make it local also. Edit inbound rules. Your 80 traffic is actually you are going to allow only to internal might be. Okay, so like let's say you can be allowing only 192.168.0.0 by 24 only, you allow it. Okay, no problem. But still it is actually accessible from the outside world because load balancer is doing that. The load balancer has that information of 0000. All right, that's fine. So now if I just, okay, if you go to the target groups, it should show healthy. It should be healthy. No target groups, seriously. Load balancers, listeners. Oh, we didn't add any. All right. So, but we added the target group, right? These are all belongs to this one only. My bad. What I did the mistake, I think, is this new instance whichever I launched is not the okay, it's still in this VPC only. All right, 1 second. Go to the target group, create a target group. There's actually instances port 80, which is fine, and this is Nginx, and this should be in the new VPC, HTTP1, and everything is fine. Next, and you have this one, and add it, create. Now you go to the load balancer, and you'll say add listener, and it's actually HTTP, forward it to the target group Nginx, and that's done. Okay, now you go back to the load balancer and try to refresh. It just takes a minute to load the configuration. Just wait for that. You see this? You're getting welcome to CentOS from the load balancer, which is running a private instance, which is a private instance. Okay, cool, clear? Any questions on this? Okay, all right. So you try to solve one problem here. Okay, what is the problem you try to solve here is standalone servers. Okay, now standalone servers also we try to achieve, so we try to achieve this also completely by using different concepts in Amazon, different concepts in Amazon. So using the load balancer and things like that, right? So I don't know. So standalone servers are now addressed, okay, with the help of so multiple nodes using ALB. Okay, using ALB, so we solve that particular problem even. Okay, so but multiple nodes are there. So how about something called as so like let's say the load is, I mean your load is something like a sine graph, right? A sine wave. Okay, so sine wave, if you take, so generally how sine wave looks like, this is the sine wave, right? So that means your traffic actually comes at peak at some time, very minimal at some time, peak at some time, very minimal at some time. So that means you cannot actually go and so take a resources either to the peak or either to the minimum, right? So you have to so when there is a need, it has to launch those many instances. When there is no need, it actually has to delete those instances. Okay, so this is how also we need to think about. So that is nothing but whenever there is a need, the servers has to get increased with the same configuration, and if there is no need, the server has to be decreased with the same configuration. So how do we do this? How do we do this? Okay, so that is what we're going to talk in the next topic, which is going to called as auto scaling group. Okay, auto scaling, scaling and auto scaling. Okay, two things are there. So scaling and auto scaling. So scaling is capability of scaling it, but you do manually scaling. Auto scaling means based on some rules and some setup. Okay, it can auto scale also. Either of the way is fine. Okay, go with auto scaling. Technically auto scaling, we should do auto scaling, and so technically we are going to do the auto scaling part only. All right, so the scalability part we are going to talk about, and even before to that, even I want to talk about the security. So the security we're actually trying to achieve a little bit, isn't it? The security we already trying to achieve a little bit, okay, by closing all our servers into the private network. Okay, so our servers are a bit secure now. All right, so and apart from this, what I mean, there's only one problem right now which we have is our application is actually exposed to the outside world over the load balancer. Okay, now the load balancer can cause load balancer can still allowing the 80 port traffic to the outside world. Now the outside people still can reach your servers, like hackers and all, not only access your content, I mean basically the HTML content, they try to look into some bugs and all, they try to get into your systems also. So over the 80 port, I mean over the HTTP server. So that's how anyone gets into the so servers and hack the data is basically you'll be having some problems with your some kind of problems with your some kind of issues whichever you are having with your application, so they get in there. Okay, so that means each and every request whichever is coming up over here, so has to be, you have to be very careful. So the only one actually we are exposing here is load balancer to the outside world. So now whenever this traffic is actually so being accessed by someone, so we should be very careful about that. Okay, so that particular one can be done now by with nothing but called as so normal firewalls will not help you. So now you require a web application firewall. Okay, we call it as WAF, web application firewall. It's for a web, basically web content basically. The previous firewalls whatever we have, those are security groups. Okay, those are network firewalls. That means they can monitor, okay, this port should be allowed or not allowed. That's it. This IP address allowed or not allowed. That's it. But now actually everyone should come to my load balancer, and at the same time I have to monitor who is actually coming and who are they basically. So now I need to add some more web application firewall, and so that I can be a little bit secure basically. Okay, so we go with the WAF and shield here. WAF and Shield are together services, which brings you certain security both together in general in Amazon. Okay, but what they are doing? Okay, let's try to understand that. So they try to address certain very common methodologies which is performed by any kind of a hackers in general. So like SQL injection, okay, so kind of thing. So they just try to there are certain rules actually. You just need to create those rules and do it. Okay, so create a web ACL. I think you can just go and say that is a test or something like that. And so here. Add AWS resources, you're going to go with and add a load balancer, and the load balancer is Nginx, and add it. Okay, so and next, and add managed rules. Okay, that means the rules which is provided by Amazon. Okay, there are a lot of rules actually. Okay, so whichever the rules you want to add, you can add it. Now let's say AWS WAF. So what actually WAF is trying to do? You see this. Written in detail, we didn't got it. Yeah, the managed rules of WAF, it addresses like WASP top security risks. Okay, top 10 security risks. WASP is a community basically. WASP is a security community. Okay, so open source foundation for open source web application security project. Okay, so these guys are actually kind of a backbone for a lot of the securities, but still it is open source kind of thing. So these guys are community basically. Okay, and yeah, so a lot of people contribute to this as well. Okay, and this has guys a lot of products. Okay, so this community has most of the people so just try to use these particular products actually. Okay, so but we're not going into that area. So now since we're actually the whatever they're telling is the top 10 security risks you get out of box in WAF basically, right? So that is actually helped me in doing it. And basically the patterns, like generally so you try to understand this. WAF is a web application firewall against your web applications or APIs, most common web exploits that may affect availability, compromise security, or consume excessive resources. AWS WAF give you the control over your applications by enabling creating the security that can block common attacks like SQL injection and CRSS basically, cross-site scripting. Okay, and rules to filter out certain patterns and you define basically, right? So very common patterns are SQL injection and so CRSS. And what all these you can understand by just by going into the YouTube. You go to the YouTube and type like so what you're looking see. So like let's say CRSS. Okay, so CRSS cross region cross site scripting attack, right? So just go that and you'll find out 2-3 minutes videos probably. You'll just watch them and you understand how that attack happens. But okay, so these are some security. So the same way like so SQL injection. What is SQL injection basically? Okay, so try to go and search for that and you will find out some 1 or 2 minute videos. Try to understand minimal. You should have some understanding on the security side. Okay, now all those certain things actually so will be addressed by your WAF. Out of box you are getting WAF. Okay, I'm not actually going to talk about creating the rules and all because that's a whole different line. Okay, but I just want to give you some glimpse on the context of how actually your security works. Okay, so the WAF, and probably I can just enable whatever I want basically. And so you're looking for SQL injection, you'll find out. So like let's say if you're running against the databases, you just put this and something like that. Okay, so if you're running some PHP application, enable this. And based on you're having some Linux operating system, enable this. Based on the based on the rules you enable, your charges will be there. Okay, so per company it's not a big deal, so that's fine. So next, what all? Just next basically, and web SQL. Okay, the web ACL will be created and it will be attached to your load balancer automatically, and all your traffic will coming up into the load balancer will be monitored by your web ACL, and okay, so makes your load balancer a little secure. Okay, so now let's say I'm sending 100 requests, 1000 requests to my application. So then this will identify automatically that I'm getting 100 requests, 1000 requests from a single IP address. It is not expected, so it will block that particular IP address. It's smart. It will automatically block that particular one. So that is what you have WAF, and also Shield also you have. So Shield AWS also, if you have another service. So this Shield is doing another set of services. Okay, so set of attacks basically. So Shield is going to be attacking the DDoS attacks, okay, which I mentioned, like continuous attacking, okay, things like that. So this okay, so yeah, so DRT also something is called as a DDoS response team, something is there. Okay, so these things also will be blocked by Shield additionally to the WAF. Okay, so this is provided as a separate service. And okay, so how do I block this? Is just again go into the Shield and so enable that. Or you got Shield, okay, here only, right? Subscribe is there. Probably watch your okay, so some internet videos. Okay, it's chargeable service. I don't want to enable and make unnecessary charges here. So just go to the internet and search for AWS Shield with AWS load balancer, and automatically you'll find out the configurations. Just take a look. Okay, and you're going to really do that also. Just take a look and understand how it is working. That's the only thing I would say. Do it. Okay, so these are costly services. I just want to delete them. Yeah, so probably that's all from my side for today. So the security is a little thing, and again I'll talk about the security in one more time in few more minutes. Okay, so I'll talk about certain vulnerability scanning. Okay, so some other time, but until then, yeah, so this is what you have here. Yeah, and that's all from my side for today. Any questions? Also, I'll try to create the VPC as fast as possible. Why? Because the NAT gateway is chargeable again. Okay, you don't get unnecessary charges. NAT gateway is chargeable. Yeah, so any questions? Questions, confusions? Okay, all right. So tomorrow, the scope of the tomorrow session is going to be okay, addressing the last point, whichever is not we have discussed so far. So security, some understanding on the security we have some now. It's not working somehow. And this is security, and yeah, and the next one which is there is scalability. So we'll talk about the scalability, and so we'll address almost all the issues, and so we'll address the remaining issues one by one with other tools. But yeah, after addressing these tools, then we start doing the automation. What all the things we talked about here, so we do everything with the Terraform. Okay, So you create a load balancer, you create a server, you create a network, you create a database, everything. You create a WAF rule, everything goes as a Terraform code, as a code. So it's a standard practice. Okay, so that's what we're going to reach in after tomorrow's session mostly. Yeah, and that's all from my side. Yeah. Any questions? Otherwise, we're done. Okay, all right. No questions. We'll meet in tomorrow's session then. Thank you. See you tomorrow. Bye.